Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create a different counter type from where we can grab some ingredients. Okay, so far here we have our character working and we have an empty counter, and by interacting with it we can spawn an object. But obviously that's not the behavior we want in the final game. We want different counter types that do different things. The clear counter should only be used as a place for putting down and grabbing objects. It should not spawn anything. So let's build a new counter type. And for that, one option is to make a brand new prefab and build it all from scratch. Another option is we can duplicate this counter and change a bunch of things. Or there's a third option that was added in recent Unity versions. You can now have what is called prefab variants, meaning that we can have a base counter and then we can make variants for all the types. So let's do exactly that to learn about prefab variants. Now first, let's duplicate this one just so we don't lose any changes. Let's rename this prefab to _base counter. Now I like to add an underscore just so that the base prefab is on top, since this window is sorted alphabetically. Now let's go inside the base counter. Let's go into the scene view, so here it is. And basically over here we only want to have all of the things that all of the counters will have. So all the counters will have a box collider, all with the same shape, so that's good. They will also all have a counter top point. However, for the visual, different counters will have different visuals, so let's get rid of this. Same thing for the selected, let's get rid of this. And on the actual object, different counters will have different scripts. So let's also get rid of this. Okay, so that's it. This is the base counter. It only has all the things that every single counter will have. So let's go ahead, save this prefab, go back outside. And now let's right-click on the base counter and go into Create. And over here, let's scroll down and find the prefab variant. Now let's name this the clear counter, except obviously we can't have two different names. So let's put this one into backup. We're going to get rid of this one in a little bit. So on the variant, let's name it clear counter. Let's open up this variant. And now here, let's add everything just like we had on the old clear counter. So since it's going to be exact, let's actually go inside the backup one. So here, let's just copy the visual in the selected. So let's copy this. Go back inside the clear counter variant, and over here let's paste it, so Ctrl V. So there it is, the selected and the visual. Finally, just a script, so over here let's add the clear counter script. And now let's just drag the references, so the kitchen object, we're actually going to remove this in a little bit, but for now let's assign it. The counter top point, let's drag it, and on the selected we also need to drag the kitchen counter reference. Okay, so here is our clear counter as a variant of the base counter. So let's go ahead, save this, and go back outside. And now we can finally delete the old prefab of the clear counter, so let's go ahead and delete this. And of course, over here on the scene, we've got some broken prefabs, so let's get rid of both these. And let's drop the clear counter variant, so let's drop it, place it over here. So let's put it on X of 0, Y of 0, and Z of 3.5. Okay, so that's the clear counter. Let's just put another one to the side, and perfectly on the side, so on an X of minus 1.5. Okay, now we can begin making our container counter. So for that, once again, let's make a variant. So right-click on the base counter, go into Create, and let's create a prefab variant. Call this the container counter, and let's go inside of it. Now here, first thing we need is the visual, so let's go inside our assets. We've got the prefab visuals. Inside we have the counters visuals, and let's find the container counter. So let's drag it inside. Again, for the local position, make sure it's all on 0, 0, 0. Okay, great. Then we need to make the selected, so let's duplicate this visual. Let's rename this to selected. Let's go inside on all of these. And let's modify the material for the selected material. So let's click on the circle icon and select the counter select material. Okay, we've got our nice little ghost icon. And just like we did previously, let's start with these disabled. So all these game objects disabled, so they are hidden. And on the selected, let's make sure the scale is 1% bigger, so 1.01. Also on the selected, this one does not need an animator, so let's get rid of this. Now let's add the selected counter visual. And obviously for this one, we're eventually going to need to refactor it to support multiple visual objects. As you can see, this selected has multiple. But for now, just make sure that it works. Let's just drag just the first one. Okay, great. So our container counter has been built. The only thing that we need is the main logic script, so let's do that. Let's go into our scripts folder. Let's create a brand new C# script. Name it the container counter, and let's select the main game object, attach a script, and let's open it. Alright, so now here let's first think what we want. For this counter, we want the player to interact with it, and when it does, we want to spawn an ingredient and give it to the player. So that means that we're going to want pretty much the exact same behavior that we made over here on the clear counter. So when the player interacts, we spawn and we give it to the player. So let's actually copy all of this code. Let's go into the container counter, and over here, let's paste this. We just need to grab the references to the kitchen object and the kitchen object SO. So again, just like we did on the container counter, let's copy all of these references. And over here, let's paste all of them. And of course, here we have an error. In order for this to work, this needs to implement our interface. So let's do exactly that. So let's implement the iKitchenObjectParent. And back in the clear counter, let's just copy the exact same code. So all of these functions, let's just copy them. And on the container counter, just paste them. Okay, great. So we don't have any more errors here, so everything should work. We should be able to interact with the container counter, and we should be able to see an object being spawned on top of it. Over here in the editor, let's just make sure to assign it. So let's assign a default kitchen object. So let's say a tomato, and the countertop point, let's drag the reference. And okay, everything else should be working. So over here on the selected, we've got the visual game object, and on the container counter, we've got this. Okay, great. So let's go outside into scene view. And over here, let's just place some container counters. So let's drag one up there. Let's place it on an X of 1.5, on a Y of 0, and Z of 3.5. And let's also place another one down here. So let's rotate it to face it upwards. Okay, so on position 0, 0, -5. Okay, great. And let's make them spawn different things. So on this one up here, let's actually spawn a cheese block. And on this one down here, let's spawn a tomato. So let's also modify the icon here. So from cheese block, and let's put a tomato icon. So here it is. Okay, we've got 2 counters and 2 clear counters, so let's test. So here we are, and if I approach the container counter and I press the interact button, and nope, nothing happened. We cannot interact with it at all. Even the selection visual, even that one is broken. So as I approach, nope, the visual is not showing up. Now the reason for this is actually pretty obvious. If we go over here on the player script, down here when we're handling our interactions, so let's go into the handle interactions function. Over here we are doing a raycast, and we are trying to get component of type clear counter. So basically we're not doing anything if that object has a container counter instead of a clear counter. So again, we have a similar issue to the one that we had in the object parent logic. Basically we have 2 types, a clear counter and a container counter, and we want the player to be able to interact with both of them. So as a solution for this exact same problem, we could also implement an interface just like we did. That would work, that would enable the player to interact with multiple counters. But in this case, since the counters are all very similar, very related objects, they're all going to be kitchen counters as opposed to object parents where the player and the counter are completely different. In this case, since they are all very similar, a better approach is actually to use inheritance. Now here, I should point out that inheritance is one of those things that is simultaneously very powerful but also very dangerous. Usually beginners get really excited when they first hear about inheritance, but after gaining some experience they start to see the massive downsides. One funny joke about it is, let's say you want to write some code that all it needs is a banana class, but because of messy inheritance you end up with a monkey and the entire jungle behind it. Basically the banana extends a monkey, which extends a tree, which extends a jungle, and so on. So you just want a small thing, but because of a complex inheritance you end up picking up a huge object. So all of that to say, inheritance is something you must use very, very carefully. It's a powerful tool, definitely, but you need to make sure to absolutely use it in the right approach for the problem you're trying to solve. Now in this case, like I said, since all of the counters are going to be very closely related, in this case it does make sense. And of course in the future, if that does change, we can always refactor. If you're a beginner, definitely go ahead and research a bit more on C# inheritance, the pros and cons. I don't have any dedicated video on that topic myself, but if you search, I'm sure you'll find tons of content. Again, it's a very powerful but also very dangerous tool, so definitely use it wisely. Over here, let's make sure we're wise, so let's use it. First thing we need to do is define the base counter class, so let's create a new C# script. Let's call it the base counter. So over here on the script, let's get rid of the functions. We don't want any default functions. And let's also make sure that we do extend mono behavior. We do want that. We still want to use this as a component. So let's leave the script just like this. Let's save it. Then let's go over here into the clear counter script. And on this one, instead of extending mono behavior, let's extend the base counter. Okay, that's it. That's the only change. And now let's go into the container counter. And over here, same thing. Let's extend the base counter instead of mono behavior. So now both these counters extend the exact same base counter script. So now if we go into the player script, so here we are on the player script, and on the handle interactions function, over here instead of trying to get a component of type player counter, let's try to get the component of type base counter. So let's also rename this, so Control RR to rename this to base counter. And of course we need to rename all these references that expect a clear counter instead of a base counter. So over here for the selected counter, let's modify the type to base counter. Then also up here, when we've got the event args, let's modify the type, okay? So over here we have the interactor, let's leave this for a bit, let's go down and let's fix this issue. So let's go down into that function to set the selected counter. Instead of this type, let's receive a base counter. Okay, so all of these errors have been solved, there's only one left, and it's this one, the interact. We see this error because obviously the base class does not have any kind of interact method, so let's add that. Now for adding methods to a base class, it's actually very simple, it's really just like any other method. So first the accessor. For the interact, we want the player to be able to access it, so let's make it public. And also since we're talking about inheritance, I should probably mention the other accessor. Now you already know about public, and you also already know about private, but there's another one you might not know, which is called protected. Basically, this one means that whatever function we define with this accessor, it is going to be accessible to this class and any class that extends it. So for example, if we had a function that was protected, the clear counter could call this function because it does extend this base class. However, the player would not be able to call this because it is protected. Now in our case, for the interact action, we do want the player to call it, so let's make it public just like we had previously. Then another keyword. For every function that we want the child classes to be able to implement in their own way, we can define it as virtual. And finally, the function signature as normal. So for the interact, we made a return void, call it interact, and we received a player argument. Okay, so that's it. That's our basic signature. For the implementation, let's leave it empty over here on the base counter. So by default, it's not going to do anything. In the game design that we're building, we're never actually going to end up with anything like this. So if we want for safety, we can just add a debug.log error to say just base counter.interact, because this should never be triggered. Also, I should point out, for a more advanced method, instead of making it virtual, you could make it abstract. And basically what that does is that forces all of the classes to implement their own implementation. So you would make this abstract and just put it just like this, as if this were an interface. But in doing so, you would also need to define the base counter as abstract and so on. So basically this is a more advanced method, so don't worry about it for now. Let's keep it a bit more simple. So let's make it just virtual void interact. Okay, great. So we have this, let's save this. And now if we go on the clear counter, over here on the interact, notice how we have a green squiggle line. Basically this is a warning, it's telling us that we are hiding the base function. Now in reality we don't want to hide it, instead we want to override it. So before the void, before the return type, we just add the keyword override. And yep, this will now override the base function. So when the player interacts with an object of type base counter, and that object is actually a clear counter, when the player calls the interact function, instead of running this code, it's actually going to run this code. Now let's do the same thing on the container counter. So over here, let's also add the keyword override to override the base function. Okay, great. So we have no errors here. And on the player, we also don't have any more errors since that one does now implement the interact function. So with this, let's test and everything should still be working. So over here, let's approach the interact counter and let's interact with it. And yep, it does work. It spawned some cheese. And down here, yep, it spawned a tomato. And then if we go onto the empty counter and interact, and yep, it still works. Okay, so here we added the ability to interact with two different counter types. All right, great. Now note how the selected logic isn't really working well. You can see the container counters, they are both selected, even though the player is not looking at them. And actually, if I approach it, then it actually becomes deselected. Basically, the reason for that is because the selected script, that one is still referencing the clear counter instead of the base counter. So right now, it's only being selected when the selected counter is null. So that is why as I approach, it actually hides itself. So let's fix this. Let's go inside the container counter prefab, and inside we've got the selected. And yep, over there we have a reference to that. So let's open up this script. And over here, all we need to do is just modify this type. So let's make it of type base counter. And let's rename this to base counter. Okay, that's the only change we need. And by the way, since we're here, let's also fix the other issue. The issue we had where we need to support more than one visual game object. So instead of having a field of type just GameObject, let's receive a GameObject array. So let's modify this to GameObject array. And then down here on the show hide is actually very simple. So let's just do a for each GameObject for the visual GameObject. In the visual GameObject array, we go inside, set it to true, and on this one we set it to false. Okay, that's it, super simple. Now let's just update the prefabs. So first over here on the container counter, let's drag the container counter reference as the base counter. Okay, great. And for the visuals, let's just drag all of them. So let's drag the counter solid, drag it on top, then the counter hole, drag it on top, then the single door, drag it, and the black, drag it. And also, by the way, over here on this counter, this one actually has an object sprite. This is the actual sprite in there, but for the selected, we really don't want that. So if I enable this GameObject, here we've got the object sprite. Let's actually delete this. We don't need the actual icon sprite to be highlighted, so let's leave it just like this. So we only have these 4 objects, and all 4 of them are on the list. Okay, that's great. So all the references in here, they're all working perfectly. So let's go back outside, let's save the prefab, let's go inside the empty clear counter. And on this one, same thing, on the selected, let's drag the insider reference. And for the base counter, let's also drag that reference. Okay, so let's go outside, save it, and let's test. And now let's see if the selected works. So as I approach this one, yep, it works, and on this one, yep, it works, and down here, yep, it works. All right, awesome. So we can interact and we can highlight our selection. Okay, everything is working great. So now that all of the code is working, we can inspect the code to see if we can refactor anything. We can see, for example, if there's any kind of common logic that all of the counters share that we should probably write in the base counter. And you can see right away that both the clear counter and the container counter, both of them implement the kitchen object parent interface. That behavior is something that all of the counters will share. So instead of defining it on each counter itself, let's actually do it on the base class instead. So let's get rid of the interface implementation here, and also on the container counter, let's get rid of that. And set on the base counter, let's implement that one. So I kitchen object parent, and for the functions, let's do the same thing. So let's cut this one from here, and let's paste it on the base counter. So okay, now we need these 2 points. So let's go ahead, copy all of this. Let's go into the base counter, paste it. Except for the base one doesn't need a kitchen object SO, so just the counter top point and the kitchen object. Okay, so there are no errors on this one. Let's go into the container. Let's get rid of the kitchen object and the counter top point. Okay, great. Now we see an error, but before we worry about that, let's actually go into the clear counter and let's do the same thing. So let's get rid of this, and down here, get rid of all these functions. Okay, so now the counter scripts are much more simple. All of the common code is now written directly on the base counter. Now for solving this, the container counter needs to know if there's a kitchen object on top of it. So now here we have an interesting question with 2 possible approaches. Basically, we need access to this object. So one approach would be to make this protected. Like I said, protected means that any classes that extend this base counter class, any of those classes can then modify that field. So like this, yep, there's no more errors. That's one approach. And the other approach is to instead keep this one as private. And whenever we want to interact with it, we simply interact through these functions. Both approaches can work, and when in doubt, as usual, you should probably go with the more limited option. So let's leave it as private and work with these functions instead. Over here on the container counter, instead of testing if the kitchen object is null, let's just test has kitchen object. So if it does not have a kitchen object, then we're going to spawn it. And for spawning over here, we could grab the actual transform follow. So this one up here, we could call this function to get it, or since that is actually going to be handled automatically when we call this function to set the parent, then let's actually not use this at all. So we just spawn it and set the kitchen object parent. Okay, great. So now let's just look at the clear counter. For this one, like I said, it's not really meant to spawn anything, so let's actually remove all of this code. This one is only going to serve to pick up and drop items. We're going to handle that in the next lecture. But for now, let's just go back into the container counter and let's do the proper logic that I mentioned in the beginning. Basically on this one, we want to spawn the object and we want to immediately give it to the player. So when we call setKitchenObjectParent, instead of passing in this, let's pass in the player reference. And that's really it. For the container counter, this is all we're going to do. So the player interacts and it spawns an object and gives it to the player. Okay, so that's it with this. As you can see, the code for all of our counters is much more simplified. So basically, it only handles the logic related to that specific counter. Everything else is on the base counter. So let's test this. So here we are, and if I approach a counter and interact, and yep, there you go, spawned some cheese and gave it to the player. Okay, great. Now, just for fun, when I made these assets, I actually included a nice animation. So if you go inside the container counter, over here on the visual, note how this already has an animator with an animator controller attached to it. You can double click to open it up. And over here you can see it's very simple. Basically just has two animations. One is the container close and one is the container opening and closing. These transitions are basically triggered by this parameter. This is a trigger parameter. So when triggers, goes into the open close, and when this one ends, goes back into close. So let's just quickly add these nice animations. However, again, as usual, let's make sure to write some good clean code. So let's not add the visual over here on the logic script. Instead, let's make a proper new script. Over here, let's create a new C# script. Call this the container counter visual. Okay, now we want to attach this only to the visual game object, so only this one let's attach, okay. And over here, the first thing we need is to get the animator. So let's store a field for the animator. And since it's on the exact same object, we can just make an awake and get component of type animator. And we just assign this field, okay. So with this, we have the animator. Now we just need to know when we should play the animation. So let's go over here on the container counter script, and basically let's make an event that we're going to fire when the player grabs an object. So let's make a public event of type, let's stick with the standard, so let's use event handler inside using system, okay. Let's name this on player grabbed object. And then down here, when the player interacts and gets an object, let's fire off this event. So invoke, let's invoke with this an event args.empty. Okay, so we are firing off this event. And over here on the visual, first we need the field for the container counter, so let's add it up here. Let's add a serialized field of type container counter. Okay, we have this field. Now let's listen to the event. But again, we're accessing an external reference, so let's make sure to do it on start and not on awake. So let's go into this one and listen to the onPlayerGrabbedObject event. Okay, so here we have the event. And it's over here that we want to access the animator and call setTrigger in order to play the animation. Again, when working with animator parameters, suddenly we do need to use strings. There's no way around that, but at least we can make it a bit more clean by defining a constant. So up here, a private const string, call it open close, and let's make sure to use the exact same parameter name, so open close. And then down here on the setTrigger, let's call this trigger. Okay, so that's it, some very simple visual logic. And now over here inside the prefab, all we need is to drag the container counter reference, so let's drag it. Also make sure that it has the animator and the animator controller. So with that, everything should already be set up. So let's go back into the scenes, save the changes, and let's hit on play. So here we are, and if I go towards the tomato and interact, and if there you go, it plays a nice little animation. All right, awesome. Okay, so here we created a brand new counter type, and we refactored our interact code to be able to interact with any counter type. The player can interact with the container counter to pick up an object. Now, the next obvious thing that we need is to enable the player to drop an object on the clear counter, so let's do that in the next lecture.